Today we're going to look at lesson 8.5, which is called factoring a trinomial with a lead coefficient of 1. So that's our objective. We're going to factor trinomials with a lead coefficient of 1. So let's talk about the steps on how we would do something like that. Anytime the directions ask us to factor, it is going to be important first and foremost that we always look for a GCF. Sometimes we might have one. It might be a number, it might be a letter, but sometimes there might not be one. But we do always want to look for that GCF because in order to factor, we have to factor completely. First step is looking for a GCF. Okay, so like I said, sometimes there might be one, sometimes there might not be one. But the next thing that we're going to do then is we are going to be asking ourselves what multiplies to the last number but adds to the number in the middle. So this is where it's going to be super important that we have a good number sense. So that's why I've always listed a multiplication table in the extra resources. It's a good idea that maybe you print off that multiplication table or always have that open when you are doing these types of problems, because we have to know numbers that multiply but also add. So obviously having a calculator by you is going to help you as well, but I think a multiplication table will also help. Okay, and then finally, we always want to make sure that we are going to write our answers as polynomials being multiplied together. So like the objective said, we're starting with a trinomial, so 3 different terms being added or subtracted together, but at the very end, our answer should be multiplication. We're going to be multiplying polynomials together. Okay, so those are our steps in order to factor with a lead coefficient of 1. So notice that the directions are asking for us to factor completely. So like I said, that's why step number 1, we have to look for a GCF. So GCF means, are there numbers that they have in common? Are there variables that they have in common? Well, because we are dealing with a lead coefficient of 1, there are never going to be numbers that we have in common, because the biggest number that we can take out of all of those would be a 1, and that's not going to change anything. So essentially what we're looking for when we have a lead coefficient of 1, so the number is in front of our squared term, is we're looking to see, are there any variables that all the terms have in common? So I see x squared, I see an x in the middle, but then the last term is just a number. So I don't see a variable in every single one of those terms. So there is no GCF. It's always, like I said, a good idea to scan that first. You don't necessarily have to write no GCF, but we had to look for that GCF first. All right, so moving on to the second step, it says what multiplies to the last number but adds the number in the middle. So my last number should be the number that does not have a variable. So we're going to be looking for numbers that multiply to 2. The number in the middle is going to be the number that is attached to the x, and we want to find numbers that add to it. All right, so we're going to always start with the multiplication aspect. So I like to always make a little chart. So here's my multiplication sign. I want to multiply to the number 2. So the nice thing about this particular number is that there is only one way to multiply to 2. That would be a 1 times 2. So 1 times 2 fit and multiply to 2. But now I have to double check that those numbers add to this 3 that I have in the middle. So if I take 2 plus 1, I'm hoping to get the number in the middle. Well, 2 plus 1, that does check out. That does give me 3. So that tells me that these two numbers of 2 and 1 are going to be a part of my final answer when I write it as a multiplication problem. So how I'm going to write it as a multiplication problem is we're actually going to be writing it as 2 binomials being multiplied together. Because this very first term is x squared, well, x times x gets you x squared. So we're going to be starting each of our binomials with an x. Because 2 times 1 is positive 2, and 2 plus 1 is positive 3, because those two numbers are positive numbers, I know that I'm going to be dealing with addition signs to create these binomials. And then literally the numbers that I just highlighted in the chart are going to be the ending of each binomial. So one of those has to be a 2, and one of those has to be a 1. I could technically switch it. I could put up the 1 first and the 2 second. That is okay. But if you need to, we could always double check that this is my answer, okay? Because if I wanted to know, do I really have the correct answer? Well, now we could do what we've been doing prior to factoring, and that was multiplying. If I have a binomial times a binomial, I could always check to make sure that I get back to what I originally had by doing some multiplication. So I could either distribute or I could do the box method. So let's say I did the box method because it's a binomial times a binomial. That means that I want a 2 by 2 box. I always want my addition signs breaking them up. So we have an x plus 2 and we have an x plus 1. I want to see, does that get me back to the x squared plus 3x plus 2 that I originally started with? Well, x times x is going to give me x squared. X times 2 is 2x. 1 times x is 1x, and 1 times 2 is 2. So if I start combining like terms, looks like we've got several x's, but everything else we do not combine. So notice how that gives me x squared. When I add my two x's, it gives me a 3x, and then we have a positive 2. So it does take me back to my original problem. So that checks out, which is why I know that the answer that I circled truly is my answer. Okay, so you should never, ever, ever turn in a homework assignment or turn in a quiz or a test and not know that your answer is correct, because you can always go back and check by doing multiplication. Okay, if we take a look at the next example, we have x squared plus 7x plus 10. So if I scan to see if there's a GCF, remember, because there's a 1 in front, I'm not going to have a number that I'm going to have in common. If I look, I'm looking to see, are there any variables in common? Well, I don't see an x at the very end, and so they don't all have x's, so there is no GCF. So that means that moving on to the second step, I get to figure out what multiplies to the last number, but adds to the number in the middle. Okay, so I'm trying to make a multiplication chart here where I have factors of 10. Well, 10 is 1 times 10. So let's see if I add those, if I get the number in the middle. Well, 1 plus 10, that's going to give me 11. I'm trying to find the number 7, so that doesn't work. So I cannot use those numbers in my final answer. Another way to multiply to 10 would be 2 times 5. So if I add those numbers, 2 plus 5, notice that this time it gives me the number that I'm looking for in the middle. So it looks like 2 and 5 are going to be the numbers that we're going to be putting into our answers. My answer is going to be a multiplication problem. Once again, because I'm starting with an x squared term, I want each of my binomials to start with an x. Everything is addition. I have a positive 7 and a positive 10. So that means I will keep everything as addition. And then, like we said, we can take those numbers that we got to multiply to 10 but add to 7, so 2 and 5, and I can put one of the numbers in one of them and one of them in the other. If you switched it around and put the 5 first and the 2 second, that's perfectly fine. Once again, I could always double check to make sure that I have the correct answer. I'm going to do the distributive property this time, so I'm going to break up that x plus 2. So we'll have an x that gets distributed to the second polynomial, so the x plus 5. And then I have that positive 2 that gets distributed to that second polynomial of x plus 5. So if I start distributing, x times x is x squared, x times 5 is 5x. If I distribute a positive 2, 2 times x is 2x, and 2 times 5 is 10. I see that I have a couple of like terms in the middle. So that takes me then to x squared plus 7x plus 10, which is the problem that we started with. So it checks out. I know that I did the problem correctly. If we take a look at the next problem, x squared minus 5x minus 6. Number in front is a 1. There is no variable at the end. There is no GCF. So I'm moving on to the second step of what multiplies to the last number but adds to the number in the middle. Now, we are dealing with negatives this time, so we do have to pay attention to the signs that are in front of the number. I want to be thinking about numbers that multiply to negative 6. So if I'm thinking about numbers that multiply to a negative, that means I'm going to have one of each sign. One of my numbers has to be positive and one of them has to be negative. So I know that 1 times 6 is going to give me 6. So how about make the 1 positive and the 6 negative? That will multiply to negative 6. Now I have to check to see if it's going to add to the middle term. So I take 1 plus negative 6. When I combine those, I get negative 5, and that is the number that I was looking for. So I found the numbers right away. Going back to the second problem, sometimes it might take you a couple of tries, but eventually you'll get there. Just make your chart and keep checking. So because those two numbers work, I know that these two numbers are going to go in my parentheses. So when I'm dealing with my parentheses, because it starts as an x squared, I need each of my binomials to start with an x. Now this is where we really have to pay attention. The 1 is positive, so I have to have a positive sign with the number 1. The 6 is negative, so I have to have a subtraction sign with the 6. And this would be my answer. And once again, you could use the box method or you could distribute and you could double check that your answer truly is. Moving on to the next example, we have x squared plus 5x minus 24. So looking for that GCF, there's a 1 in front, so there's no numbers that they're going to have in common. I don't see a variable in every single term, so there is no GCF. So that means that we move on to what multiplies to the last number, but adds to the number in the middle. Notice that my last number is a negative number. It's a negative 24. So I want to start thinking about numbers that multiply to negative 24. There are quite a few numbers, so we're going to have to kind of start building our table to try to get that positive 5 when we add. But remember, if it's a negative, I want one number to be positive and one number to be negative. So if we think about numbers that multiply to negative 24, well, 4 and 6 do. So let's make the 4 negative and the 6 positive. Okay, so those definitely multiply to negative 24. If I add them together, negative 4 plus 6, that's going to give me positive 2. That's not what I'm looking for. Even if I switched the signs around, hopefully you notice then if I made the 4 positive and the 6 negative, I'd end up getting a negative 2. It's still not the number that I want. So that just means that 4 and 6 are not going to be the numbers. So we have to think about something else that multiplies to negative 24. So how about 3 and 8? Okay, I'm going to make the 3 negative and the 8 positive. So if I multiply them, I'll get my negative 24. If I start adding them, negative 3 plus 8, that does give me the number that I'm looking for in the middle. So that means that negative 3 and positive 8 are the numbers that are going to go in my final answer. But remember, my final answer is not just those two numbers. We have two binomials being multiplied together. Because we're starting with an x squared, I want each of my parentheses to start with an x because x times x is x squared. The 3 we made negative, so whichever parenthesis I put it in, I have to keep the negative sign with the 3. Because the 8 is positive, we have to put an addition sign with that number. And this is my answer. last example we're going to look at, we've got x squared minus 6x plus 9. So if I start looking for a GCF, I don't see a number that they have in common because we have a 1 in front of the x squared. I don't see a variable in every single term, so there is no GCF. So we move on to what multiplies to the last number, but adds to the number in the middle. Okay, so we want to find numbers that multiply to 9. Well, 3 times 3 multiplies to 9. If I add those two numbers, 3 plus 3 gives me 6. This is where you have to be careful. The number that I have in the middle is not 6. It is negative 6. So, because I ended up with a positive 6, but I want a negative 6, 3 and 3 are not my answers. But it's pretty close because all I have to do is have that 6 be a different sign. So this is where we have to once again pay attention to the signs that I have in my trinomial. Because I want to multiply to a positive but add to a negative, another way to multiply to a positive besides two positives is multiplying by two negatives. A negative times a negative will give me a positive. So negative 3 times negative 3 will give me positive 9. If I add those two numbers, negative 3 plus negative 3 will give me negative 6. So both of those had to be negative in order for me to get that pattern correct. So when we're filling in those parentheses, we start with the x's in each of them. And in this case, both of the numbers that go after the x's are going to be negative 3. And once again, you can always double check by doing the box method or distributing to multiply it back out and making sure you get your original trinomial.